This is our study guide for our test on Unit 4, aka Chapter 5. So listen closely, there will be some things I reminded you in class, but in case you tuned out for a moment, you can pick them up in the video. So first question, write the polynomial in standard form. So when you have something in standard form, you've got to make sure that the expression is as simplified as possible. So in this case, we will need to distribute our expression through our parentheses. And when we do that, that gives us positive 10x to the fourth minus 8x to the fifth. So when you write a polynomial in standard form, remember that your exponents need to be in order. Okay, you write it, the leading term, the first term should be the one with the highest exponent. So that means it's going to be negative 8x to the fifth plus 10x to the fourth. So now that is in standard form. Okay, the next one says classify it by degree. You're looking for the highest exponent, so it is a fourth degree, and we call a fourth degree a quartic polynomial. And then it says classify by the number of terms. So we have a term is anything that is separated by a plus or minus. So this, if it was one term, it'd be a monomial. Two terms is a binomial. Three terms is a trinomial. And anything more than that, we say that it is a polynomial of, and tell how many terms it has. And so this case, it's of 4 terms. Now, on the test tomorrow, these two questions will be combined. I'm going to give you one to simplify, and you're going to tell me what the name of it is. Or give you one, you would say it's a quartic polynomial of 4 terms. If you did this one, it would be a quintic binomial. So just keep that in mind when you do it. Okay, number 4. Consider the leading term of each polynomial function, and then what is its end behavior. Okay, so the leading term is the one with the highest exponent, and you got to pay attention first of all to the degree, and so the degree here is odd, and then you pay attention to whether it's plus or minus, and this time it's negative. So odd negative, odd positive is like our cubic that does this, and so that's a down up. So an odd negative is going to be up and then down, and that's all you have to write. Don't give me the arrows, give me the words up, down. Okay? I don't know if we should put that in there. Let's go through that. Make it, oopsie. Let's go up, comma, down. Alright. Okay, next one. Leading is the highest exponent. So it's 7x to the fourth. It is positive. So again, my degree is an even number, and there is no negative sign in front of it. So it's even positive, and even positive goes up and up. Okay, I need to pause. Okay, our next problem says, what are the zeros of the function, what are their multiplicities, and use this to sketch the graph of each function. That's supposed to say function, I cut it off. Okay, so what do? First off, is you can factor this problem. So hopefully you see there's a common factor of x squared. So, and basically I'm setting it equal to 0. So I'm going to take out x squared and have x squared minus, that's not 4. X squared minus 4x plus 3 equals 0. And it will factor again to x minus 3, x minus 1 equal to 0. So we set each factor equal to 0. X squared equals 0. X minus 3 equals 0. And x minus 1 equals 0. So that tells me that my zeros, okay, the resulting 0 here is 0, but when it asks for multiplicities here, it's just the exponent on the factor. So the one that gave me 0 has an exponent of 2, so that means its multiplicity is 2. X minus 3 has an exponent of 1, so its multiplicity is 1. And again, x minus 1 is the 0, but it has a multiplicity of 1. So these are your zeros. go see if I can grab that. And when you do it on the test and I give you something like this, all I'm looking for, oh good, I'm not in the way. So I have a 0, and then 1 is a 0, and then, oh, technology, don't do this to me. 2, 3 is another 0. Okay, now the other thing that we had to figure out before, we got to know where it starts. So we're looking for the end behavior. So I have a 4th degree. So if it's 4th degree and it's positive, even positive means that it goes up and up. So it's looking like that. So I know that this one is going to go up, and I know that this one is going to go up. Now I haven't connected it yet because I'm looking to see. If it's a multiplicity of 1, then we know that it goes straight through. And I'm just saving you some time right now and knowing that you don't have to tell me how high it goes, so you don't have to plot anything in between. If it has a multiplicity of 2, then it comes down and goes back up the same way it came. And then make sure you don't make them pointed. It's supposed to be curved. So that's what I'm looking at. Okay, so over here we go factor. There's a common 4x. So 4x leaves me with x squared minus 3x minus 4. And I'm going up. I don't know why I'm writing slanted. Sorry. Equals 0. So 4x, and that gives me x minus 4, x plus 1 equal to 0. So I have 4x equals 0. I have x minus 4 equals 0, and I have x plus 1 equals 0. Okay, so that tells me if I divide both sides by 4, then my 0 is 0, because 0 divided by 4 is 0. Each of these has a multiplicity of 1, because there is no exponent other than 1 on these. So I have 0. When I add 4, I'm going to have 4 as a 0. And when I subtract 1, I'm going to have negative 1 as a 0. Excuse me, that's a multiplicity of 1. So these are my zeros. Okay, and we go plot those zeros. I have 1 at 0. 1, 2, 3, 4 is a 0. And then negative 1 is a 0. So these are my zeros. And then I'm going to look and I'm going to say, okay, this one is odd positive. Okay, and odd positive, odd negative went up, down, so odd positive is going to go, actually I'm going to do my little arrows instead. It's going to go down and then up. And these are all multiplicity of 1, so I just know that I have to start down, go up, come back down, and go, and let's try not to miss. Let me try that one more time. And then I'm not going to make you watch me make an idiot out of myself on the video. That's close enough. Y'all can do better with pencil and paper, but make sure that it's curved, not pointy. Okay, what is a relative max and min? Okay, so I don't have my Inspire ready. Give me 1 second and I'll be right back. Okay, so 8, 9, and 10, all three require a graphing calculator, and as I mentioned in class today, these 3 problems have been placed at the end of the test because I will keep your graphing calculator and give you the graphing calculator the last 5 to 10 minutes of the class to do those 3 problems. So don't rely on them to do any other part of the test. Okay, so when you get to your graphing calculator, hopefully everybody knows how to get to this graphing screen, and we're going to go put in that first function, which is x cubed, come back down, plus 3x squared minus 24x, and you graph it. Okay, and it's really important for you to know how to change these. You can go to menu, you can go to window, and you can go to window settings. Okay, if you want to go do it that way, and you're not really worried about your x-axis as much as your y-axis. So they'll let me move it, they won't let me move it. Okay, I can't see the minimum or the maximum, so I need to make these numbers bigger. So I'm going to go to negative 20, and let's go to 40 and see what we can see. I still can't see them. So that is one way to do it. The other way is you can click on, and if you hit tab, it takes you between the numbers. So let's go to 85 this time, and I'm going to go to negative 30. Okay, now I can see both of them. You have to be able to see the max or min in your window to be able to use the next feature. So if I'm looking for a relative max or min, then I'm going to hit menu, analyze graph. We can do the minimum first. keep in mind that any graph can have more than one relative max or min. A min is, of course, any valley in your graph, and a max is going to be any peak in your graph. So I'm going to go on the left side, and I'm going to go on the right side, and there is my minimum, and I'll go write that down in just a second. And then to go find the max, I am going to analyze and go to a maximum, and again, the left side of that peak and the right side of the peak, and then it tells me what that. So that's my maximum, and that right there is my minimum. So let's go put that back on our paper. So we have relative max, and a relative max ended up being at negative 480, and then we'll stay with that one. A relative min is at 2, negative 28. Okay? All right, number 9, going back to my graphing calculator. Now, the important thing to do, and really what I would like for you to do in your paper so I know if you've made a mistake, but when you do this problem, remember that you do need to set it equal to 0. Does it matter that it's in standard form? Absolutely not. So just put it over there as easy as you can. So I know to subtract that, so I'm just going to put it there, and that's what I'm going to put in my calculator. So I'm going to go back, and on our Inspire, I think it best if you get a new page, which is above document, but notice I have to hit the control button first. So I'm going to hit control, new page, sorry, got to get out of my smart ink here, control, new page, and I'm going to graph again. So what am I going to graph? It was negative 5x cubed, come back down, plus 10x minus 4x squared. And I'm going to graph it. All right, and this time the directions, I'm not looking for a max or min, I'm looking for zeros. So I need these numbers here. Okay, that one clearly doesn't go through. That looks like it goes through at 0, and that one looks like it goes through at 1. So what I want to point out to you, easy thing to remember, excuse me, on here, if you hit Control and T for table, you pull up a table, and you can see that the graph is real skinny right next to it. So we thought there was a 0 at, it looked like it's at 1, but if you can see, the value of 1 is not 0, okay? So if I go up to 0, because I have 0 right here, then I know that this 0 is a 0, and the other one we know is not, okay? But you can see clearly, if 1, it looks like on our graph that it goes through at 1, but if you look at your table, 1 does not give you a 0, so it's not a 0. So Control T puts your table on and takes your table off. So I know this is a 0, but I need to go figure out these other two. So once again, we hit Menu, Analyze Graph, 0. Got to be on the left side of the 0, right side of the 0, and there it is. It's at negative 1.87. And now I have to go find the other one. Menu, Analyze Graph, another 0, and I'm going to be on the left side and the right side, and you can see how close it is. It's 7/100ths of a way. Okay, so when you write in the answer blank, I've got those two that I found. Okay, negative 1.87 and 1.07. So my real solutions are x equals, it was negative 1.87 and 1.07. Lunch bell. Okay, keep in mind, y'all, from the last section, it's a cubic, so I need to have 3 of them in there. So if you remember, the last one we found in the table, and that was 0. So 5.6 is something that you can use all through the test. Okay, so let's look at this one. It's going to become x to the 4th minus x squared minus 12 minus 4x cubed plus 16x equals 0. So I'm going to go back to my Inspire and put that in. Control, document, another graph, and I have x to the 4th, make sure you come back down, minus x squared minus 12 minus 4x cubed, come back down, and then plus 16x. And I wrote 15, smart, 16x. So x to the fourth minus x squared minus 12 minus 4x cubed plus 16x. And here is my graph. Now, look at these. I have 1, 2, 3, 4, and they look like negative 2, 1, 2, and 3. So I'm going to go look on my table. Control T for table. Well, there's 1, 2, and 3. See, they have zeros, so the roots are 1, 2, and 3. Let's go see if we had another one at negative 2. And there we do. So we don't have to go through that process of analyzing the graph because we could see it from the table. So I'm going to go write those in and move along to the next problem. X equals negative 2, 1, 3, and 2. Okay, divide using long division. Got a visitor? Give me 1 second, please. Okay, moving right along to our long division. Okay, so divide using long division. Remember, this is our divisor, so this is what's going to go outside. So I have x squared minus 2. And when I do this, I kind of say the degree to myself, or well, either way. So this is x to the fourth. I should have x to the third, which I don't, so I'm going to put my 0 placeholder, 0x to the third minus 2x squared minus x minus 2. So I'm checking 4, 3, 2, 1, 0. Okay, so x squared times what gives me negative 3x to the fourth, and that of course is negative 3x squared. So I want to multiply that, I get negative 3x to the fourth, and then negative 3x squared times negative 2 is positive 6x squared. And I put parentheses around it because I'm going to subtract. That's the same thing. Negative 2 minus 6 is negative 8x squared. And then I'm going to bring down my next term, so that's going to be minus x. And so x squared times what gives me negative 8x squared? And that answer is negative 8, so I'm going to write it over the negative 2, and that also kind of lets you know that I'm going to have to bring that down because I'm going to end up with a constant term. Okay, it doesn't matter if you figure it out, but if you notice here, we actually had 3 terms that we were dealing with. So negative 8 times x squared is negative 8x squared, and negative 8 times negative 2 is positive 16. So when you subtract, those go away. Negative x minus nothing is negative x, and negative 2 minus 16 is minus 18. So my answer that I would write in the answer blank would be negative 3x squared minus 8. And if you want to write plus negative x minus 18 over the divisor, that would be the proper way to write it. Okay. The better way, if these are both negative, you can put the negative out here and make them positive, but we don't have to worry about that right now. Okay. All right, next one. So we go to dividing this one by x plus 4. So I'm going to have x plus 4 as my divisor. And then I have x to the third plus x squared minus x plus 2. Didn't skip anything, so that's nice. So now I'm going to divide x times what is x cubed. And that gives me, that is x squared. X squared times x is x cubed. X squared times 4 is 4x squared. So when I subtract, these cancel out. And x squared minus 4x squared is minus 3x squared. Bring down my next term. X times what is minus 3x squared, and that's minus 3x. So minus 3x times x is minus 3x squared, and minus 3 times 4 is minus 12x. So I subtract that, and again, first terms give me 0. Minus x minus a negative 12 is going to be 11x. Bring down my 2. X times what gives me 11x? And of course that is 11. And 11 times x is 11x, and 11 times 4 is 44. So when I subtract, I get, that cancels, 2 minus 44 is negative 42. So my answer that I'm going to put in the answer blank. This is my quotient, so I'm going to write x squared minus 3x plus 11, and then minus 42 over x plus 4. And that is our answer. All right, use synthetic division to find p of, I skipped 13 and 14. Hold on, let me find them. I'll be right back. Poof, they're back. And, of course, I didn't give enough, or maybe I put them on the next page. Let me see. 13. There it is right there. All right, so forget that. So 13, because I thought I was giving room for all of them. Okay, so synthetic division, remember that this is my factor, then I set that factor equal to 0 to figure out what the related root is. So 4 is what I'm going to use for my synthetic division. So I have x cubed, x squared, x, and 6. And that's going to be my remainder. So I'll bring it down, negative 4. 4 times negative 4 is negative 16. 21 minus 16 is 5. 4 times 5 is 20. Negative 21 plus 20 is negative 1. And 21, hold on, I copied it down wrong. That's because y'all aren't here yelling at me. Sorry, that's supposed to be, it just changes this. I think we're okay there. All right, so that's 23, and then 23, negative 23 plus 20 is a negative 3, and then 4 times negative 3 is negative 12, and 6 plus negative 12 is negative 6. So what am I going to write in my answer blank? These are the coefficients of a now second degree. So I'm going to have negative 4x squared plus 5x minus 3, and then minus 6 over, this is my factor, so it's over x minus 4. Okay, look at the next one. All right, x plus 4 equals 0, meaning that my, my related root is negative 4. So I have negative 4 here, and then I have x cubed, x squared. I don't have an x squared, and then an x term, and then a constant term. And this will be my remainder. So bring down my negative 14, and negative 4 times negative 14 is 56, and 0 plus 56 is 56. Negative 4 times 56 is negative 224, plus 14 is negative 210, and negative 4 times negative 210 is 840. Woohoo! Because I got a remainder of 0, which means that it goes in evenly. So what I'm going to write in my answer blank is 14x to the what? Started with a third, so I'm ending with a squared, plus 56x minus 210. And that's what I get when I divide. Okay? Now, you will also have a question that looks like this for synthetic division. Use synthetic division to find p of negative 2 for that polynomial. So if I give it to you like p of negative 2, you don't have to do any of this stuff. You already have the number that you need. So I start with negative 2. 1x to the 4th. There's my x cubed. I do not have an x squared. There's my x, and there's my constant. So that gives me, and this is my remainder, but that will also be the answer to the problem. So bring down my 1, negative 2. 9 minus 2 is 7. Negative 2 times 7 is 14. 0 plus 14 is 14. Negative 2 times 14 is negative 28. That's supposed to be a negative 14. That's supposed to be a negative 14. That makes that a positive 28. Negative 9 plus 28 is 19. Negative 2 times 19 is negative 38, and 2 plus negative 38 is negative 36. So in the answer blank, you can either write just negative 36, or you can tell me that p of negative 2 equals negative 36. Oh, poof, sorry, that was a bad box. Oh, and he took away my 6. All right, moving on. Write a polynomial function with rational coefficients so that p of x equals 0 has the given roots. So what's important is to remember if you see an I in there, you got to have its conjugate. So if it's 2 plus I, you have 2 minus I. So what we did was we said x equals negative 4, x equals 2 plus I, and x equals 2 minus I. So what do you do from we take each of those and set them equal to 0. So I'm going to add 4, and then I'm going to bring that over, so that means I would subtract the 2 and the I, and again I would I would subtract the 2, but this time I add the I. Okay, and now as we have talked about, each of these is the factor of your polynomial. So what you're writing is p of x equals x plus 4 times x minus 2 minus I, x minus 2 plus I. And so carry down your x plus 4, and this is the one that we have talked about before, okay, that these two will always be the same, and the last two will always be the same. So that's your a plus b, a minus b. So when I write it out, it's going to be x minus 2 squared minus that other one squared. So that gives me x plus 4, and then x minus 2 squared, we've done this a lot, is x squared minus 4x plus 4. That's your a minus b, a squared minus 2ab plus b squared. And then what is I squared equal to? I know you all know that I squared is negative 1, so minus a negative 1 is equal to plus 1. So the last step that you have to do, p of x, is just simplify that last one. So you have x plus 4 times x squared minus 4x plus 5. And you are good to go at that point. Okay? So, next. Alright, so again, I have the square root of 6, and after the square root of 6, then I'm going to have the negative square root of 6. These don't have a radical or an I in them, so I'm not worried about them. So that's going to give me, I don't know how, oh wait, I can almost skip that step. So my roots are x equals negative square root of 6, x equals the positive square root of 6, x equals 5, and x equals negative 3. So I set them equal to 0, and I didn't do that. X plus the square root of 6 equals 0, x minus the square root of 6 equals 0, x minus 5 equals 0, and x plus 3 equals 0. So if I highlight that, okay, there's anything on the other side from 0 is the factor that you're going to put in your polynomial. So that gives me p of x equals x plus the square root of 6, x minus the square root of 6, x minus 5, and x plus 3. So these two, this is a plus b, a minus b. So that's x squared minus that squared, and the square root of 6 squared is 6. And then there's a binomial that we can combine, so I do want you to do that. So that gives me x squared, if you want to go outside, plus 3x minus 5x minus 15. So you just got to simplify that last trinomial and carry everything else. X squared minus 6, and then x squared minus 2x minus 15. And that's as far as you have to go. Okay, use the rational root theorem to list all possible all you do is list them, y'all, possible rational roots. So this is where we take the factors of 8 and we put it over the factors of that coefficient, which is 1. So really it's just the factors of 8, plus or minus 1, 2, 4, and 8. Okay, that's all it is. Okay, this time, again, I like the visual. factors of 5 over the factors of 2. So I'm going to list the factors of 5, which are 1 and 5, and the factors of 2, which are 1 and 2. And that gives me, plus or minus, you always list the top, and then I have to put each of those over any other factors in the bottom. That's not 1 over 5, 1 over, okay, having a little difficulty there. It's 1 over 2 and then 5 over 2. So that would be your possible rational roots again. Okay, what does Descartes' rule of signs tell you about the real roots of your polynomial? So we look at the sign changes. This is positive to positive, not a sign change. Positive to negative is one sign change, and negative to negative is not a sign change. So that means that I have one positive real root. Okay, so what's happened is I'm just looking, see, I only put the little hump when I have a sign change. So I'm looking at that, and all I'm looking to see is when it goes from positive to negative. Now, to find the negative real roots, I go and change the odd exponents. So if this is positive, it's now going to be negative. So I have negative, positive, negative. That's an odd power because that's the first, so that's going to change. And that doesn't ever change. So here's 1, that's not 1, and there's 2, so I'm going to have 2 or 0 because we always go down by 2's. Why can I not put a box around my answer very well? Okay. Alright, let's look at another one. Again, I don't know, I'm going to write these answers down below. Okay, so negative to a positive is a sign change. Positive to a negative is a sign change. Negative to negative is not. So I have, I wonder if I can make this smaller. Let's see if I can make this smaller to give me some more room. Group. All right, there we go, if that helps. Okay, so let's write this answer here. So I have 2 or 0 positive real roots. And then I change all the odd powers. So this one is now positive. He doesn't change. He becomes positive, and he doesn't change. So I only have one negative real root. So that's how you do Descartes' rules. I hope y'all got that, because that's an easy one. Okay, find the roots of the polynomial. So you can do p over q. These problems here, y'all, this says find the roots. This says what are the real or imaginary solutions. They're all asking the same thing. I just want you to be aware that they're different directions, but they're asking the same thing. Okay? Now, when I look at this, you can, first off, I'm not going to deal with a negative number, so I am going to go in here, and I'm going to multiply everything by -1. So that's going to give me x cubed minus 5x squared plus, actually I'm going to write it over here, x cubed minus 5x squared plus 11x, and then minus 55 equals 0. Okay, so if you can't see to factor it, then you could go find the factors of 55 and go use synthetic division to get it down to numbers that you know or a quadratic that you know of. But I do happen to notice that these have something in common and those have something in common that would give me, so this is x squared, which is going to be x minus 5. This has a common 11, and I'm left with x minus 5. And so I see now that I have a common factor of x minus 5, leaving me with x squared plus 11. So then I take each of those factors and set it equal to 0. X minus 5 equals 0, x squared plus 11. So on the test tomorrow, are there going to be any like this? If you can see to factor it, yeah, you can factor it and it'll be a lot faster. If not, then you'll have to go through the other process, which is longer. But I think most of them will be able to be factored. So this tells me that x equals 5, because I'm going to add 5. And this one, I got to take the 11 over, which gives me negative 11. So x equals plus or minus. Remember, let's do this. When I take the square root of both sides, that's a negative underneath that radical. So I'm going to have, actually I'll write it right here, plus or minus, get that out of the way, plus or minus I, and 11 is not a perfect square, so it stays underneath the radical. And as I said, our last section, that fundamental theorem of algebra tells us how many roots should I have? I should have 3 of them. There's 1, and then the plus or minus is 2 and 3. So we're good to go. All right, 23. Let's see this. I'm gonna actually go down here and work it, and then I'll put the answers back up there so you can check it quickly. But here's 23. We got to bring the x to the fourth over, so that's x to the fourth plus 21x squared minus 100 equals 0. This is quadratic-like. If ever this exponent times 2 equals that exponent and you don't have any other variables in there, it's quadratic-like. So act like that's a 2 and a 1, and you would factor it to x plus 25 and x minus 4. Because you're looking for those factors of 100 that subtract to give you 21. Now, it's not just x and x squared, so it's x squared and x to the fourth, which means these are actually x squared. So I'm going to take each one and set it equal to 0. X squared equals, excuse me, tried to skip a step on you. X squared minus 4 equals 0. So this gives me x squared equals 25, and this gives me x squared equals 4. So when I take the square root of both sides, since that's the easiest way to do it if you have no b term, okay? When I write my answers, if I have, look at that. Y'all probably yelling at me again. Negative 25. I don't know, I don't think I had that negative, but you couldn't see it. But the whole point of that was to say, if you have a negative underneath here, y'all, when you write those answers, x equals plus or minus always when you take that square root. But if there's a negative underneath there, that's going to give you the I. The square root of 25 is 5, so that's going to be 5i. There's no negative here, so that's going to be plus or minus 2. And what degree is it? It is a fourth degree equation. I have 1, 2, 3, 4 roots. All right, 24. I'm going to go across, I think. So go to 24 next. Okay, bring it to one side. X cubed minus 216 equals 0. That becomes x. You take the cube root of both. These are two perfect cubes. So x minus 6 times. Now I'm factoring with this guy, or I'm going to finish with this guy. So I square the first term, change the sign, multiply them together, and then square the last term. So I have x minus 6 equals 0. So I'm going to write x equals 6 in my answer blank. This guy is always prime, so I have to complete the square or use quadratic formula. And y'all know me by now. If that's even, I'm going to complete the square. So that's going to give me x squared plus 6x plus something equals negative 36 plus something. Okay, why did I write a 1? Because my blank was perpendicular. Okay, what goes in that blank is 1/2 of 6 squared. And then I square it out over here. Okay, so that gives me, this always factors to from a PST, x plus 3 squared equals negative 25. Nope, negative, not 25, negative 27. There we go. So if it's negative 27, and now I'm going to take the square root of both sides. Okay, there's that negative under my radical, so I know that my answer is going to have an I in it. So that gives me x plus 3 equals plus or minus I. Actually, I know that 27 is 9 times 3, and that's a perfect square. So this is going to be 3i square roots of 3. I'm glad we've already done that chapter. Okay? And then, of course, you take the 3 to the other side. So when you write your other answers, you're going to have negative 3 plus or minus 3i square roots of 3, and I'm trying to squeeze that in. Okay? So those are the answers for 24. 25, 5 is going to need a little bit, well, maybe not. Let's see if I can squeeze it in. Okay, 25. Actually, you know what I can do? I can make this guy a little smaller. Can I? Will it let me? Sorry to make y'all wait. Boom, boom, boom. There we go. Now I can fit 25 up here. All right, so 25. I'm going to bring it all to one side, but also I see a common factor of 6x. So when I bring it to one side, actually, y'all, you don't even have to because it's an equation. I can divide it by 6. Okay, so that gives me x cubed minus 10x squared. I'll go ahead and do this so I don't skip too much. All right, x squared minus 10x squared equals negative 24x, right? So when I bring it over to one side, okay, and I do have a common x, I'm going to take that x out. So that leaves me with x squared minus 10x plus 24 equals 0. So we set each one equal to 0, x equals 0, x squared minus 10x plus 24 equals 0. It factors to, oh, you could have kept factoring there. I'm loony today. You could have factored earlier. So that gives us x minus 6 equals 0 and x minus 4 equals 0. So my roots are, how many should I have? 3 of them. X equals 0, 6, and 4. 0, 6, and 4. Okay, I have less than 4 minutes to finish going here, so I will be done. Which makes it about 45 minutes. So, not too bad. Okay, y'all all know, set each of those factors equal to 0, and that's going to give you, I'm going to write it up here. I'm going to write it over here. X equals 0. When I add 2, x equals 2. When I subtract 2, I mean 5, x equals negative 5. So that's the easy one. All right, 27. 27 is a lot like 24. Okay, it is 2 cubes. So I'm going to start off by factoring. The cube root of 125 is 5x. Cube root of 343 is 7. Then I square the first term, change the sign, multiply them together, and square the last term. And then that gives me, I'm setting that one. See, that's what I was thinking I was doing there. I just did it too early. 5x plus 7 equals 0. So 5x equals negative 7. So x equals negative 7 over 5. And then this one again, remember it's prime, okay? So it's prime. Here's my A, here's my B, and here's my C. That's an odd number, and A is not 1, so I am not going to complete the square. So we say that B equals, not B, hello, x equals negative B plus or minus the square root of B squared. Got to put those parentheses around that negative number. Minus 4 times A times C. All over 2A. And so that becomes, obviously that's 35, plus or minus the square root of negative 3675 over 50. Okay? And I told y'all in class today that whenever you're doing the quadratic formula with something that came out of a perfect cube, 3 will always go into that number. So if you divide 3 into that number, it's going to go, I don't know what it is, but it's 3675. Pause real quick, I'll find out what it is. It's 1225. Okay, but it will always happen that way, so it will help you get the simplest answer. So x equals, and the square root of 1225 is 35. So 35 plus or minus, can't forget my I there, so it's 35i square root of 3 over 50. And I see that 5, I think it's 5, yep, 5 goes into each of those numbers. So when I write it up here in the answer blank, I'm going to write 35 divided by 5, which is 7, plus or minus 7i, square root of 3, all over 50 divided by 5 is 10. So those are our answers. Okay, last problem. Let's see how fast I can do this. 28. Okay, x to the fourth minus 20x squared plus 64 equals 0. Very similar to the first one. It's quadratic-like, so I'm looking for the factors of 64 that add to 20. And it's x squared minus 16 and x squared minus 4 equals 0. Set each factor equal to 0. X squared equals 16. X squared equals 4. So x, I'm going to go write it up here so I can be done. X equals, I'm taking the square root of both sides, y'all. Square root of that. I don't have any negatives in here, so there will not be any I that you have to worry about. So x equals plus or minus 4, and x equals plus or minus 2. And we are good, and I'm just over 46 minutes there. All right. If you have any questions, email me or come see me.